Hi, my name is Aditya, and today I'm going to be talking to you about Agentic AI and something very exciting in it called A2A protocol, which is agent to agent protocol. Let's see what it is, and I will show you some examples running also so that you can understand it better. Google created an agent to agent protocol. So, just like the MCP model context protocol, which integrates tools into agents, agent to agent protocol. Uh, it allows you to create generative AI agents built on diverse frameworks by different companies running on separate servers to communicate and collaborate effectively as agents, not just as tools. A2A aims to provide a common language for agents, fostering a more interconnected, powerful, and innovative AI ecosystem. A2A agents can discover each other's capabilities, negotiate interaction modalities like text, forms, media, etc., securely collaborate on long running tasks, and operate without exposing their internal state, memory, or tools. What this means is there are many agent frameworks like AutoGen and Semantic Kernel from Microsoft, Crew.ai, there is NA10, there is LangChain, LangGraph. And if you build agents or if you have to create a workflow or some collaborative solution that works across and utilizes all of these agents in different frameworks, then A2A protocol is for you. But Google A2A protocol is very complicated to implement and it has a lot of details that you need to get it right. So today we are going to use a different framework for A2A, which implements the A2A protocol, but is very simple to use and has native integration with LangChain, LangGraph, etc. So when you download the demo code, you will get a folder structure like this. There is a README file. It tells you how to create the environment. You have to install this Python A2A with all packages, all dependencies. So this is the Python A2A framework we are going to use that implements the A2A protocol instead of the Google A2A implementation. And you have to install the LangChain OpenAI package for one or two examples where we are creating some agents. So how do you create an agent using the Python A2A package? You define the agent, the name, the description, and the version. And then in the class, this is an annotation at agent. And this is inside the Python A2A package. So you define the class as an A2A server and define a skill. Agents have multiple skills that can be discovered by other agents. So the skill is to get the weather, to get the current weather for a location. Tags is weather and forecast, and get weather is the skill, and handle task is a method that processes some text and gets the weather and returns the result and the status as completed, or returns the result as more input required. This is important because LLMs sometimes don't give perfect outputs to each other. And if the message to the other agent is incomplete, the other agent should have a way of saying that more input is required. And then you simply run the weather agent on 5001 port. So let's run this. Python 01. Now it is running on 5001 port, but you cannot see anything in action. So let's go to the next example. You can create a network of agents. Why a network? Because they are communicating over the wire, over the network. So assume you have three agents, the weather at 5001 port, the hotels agent at 5002 port, and attractions at 5003 port. Now we have only one weather agent running right now at 5001 port, but you can create an AI agent router using an LLM, client, A2A client. And now when you give a query, what's the weather like in Paris? The router needs to route it to a correct agent. So it will return the agent name and the confidence level. And then from the network, you get the agent and then ask the agent the question, what is the weather like in Paris? So you are asking the question, what's the weather like in Paris two times. First time the router returns the agent and the confidence, and the second time the agent is going to answer. And here I am printing all the agents available on the network. So let's run this example. So it will create an agent network of three agents, of which only one is active, and it will route the query to the right agent. This will take some time to set up. Let it run, let it run. Hopefully it should give the right agent. Yeah, so it says routing to weather with 50% confidence. And the response from the weather agent is it is sunny and 50%, 75-degree Fahrenheit in Paris. Available agents are weather, hotels, and attractions. So if you go back to the weather agent, you can see it has a mock implementation which will return it is sunny and 75-degree Fahrenheit in location. So this is how you get agent servers and agent networks to work. And similarly, this is a workflow agent. I won't be running it because I don't have three agents ready. You create a network just like earlier, a research agent, a summarizer, a fact checker, and then you create a flow and then ask the research agent to research the latest developments in a certain topic. Okay. And then what you do is you run a parallel flow between two agents, summarizer and fact checker, where you ask the summarizer to summarize this research and the fact checker to verify the key facts from the latest result. And then you execute the function and you get the parallel results, you run it and you get the results and you print the results and you exit. So this is how you're going to create a workflow of agents within the network. I don't have three agents running, so I have not implemented it, so I cannot show you the workflow in action. But what about converting MCP tools to LangChain tools? For example, we had created an MCP tool earlier in the MCP example, which is a calculator and which calculates some mathematical calculation. So here I have an annotation and I'm running a fast MCP server here, which is going to expose a calculator MCP tool on the given port, and then from that network port of localhost and 5000, I'm going to convert it into a LangChain tool, and I'm going to run the LangChain tool with what is 5 into 9 plus 3 and print the results. This calculator tool can is now a LangChain tool and it can be used in LangChain workflows. So you can take a MCP server tool and include it into your LangChain workflows. So let's run this example. It is running the calculator tool on 5000 and the result is 48. So you can see the fast MCP server the fast MCP server has evaluated. This is a simple, we're not using an LLM, we are simply evaluating the statement. In Python, you can evaluate a string of expressions. So this is an evaluate Python evaluate function, and you simply return the result. So what do you do if you have to expose a LangChain tool as an MCP server? Here you see this. A LangChain tool is simply a function. I have shown you in the MCP demo. It is simply a function, and you can create a tool using LangChain tools tool method, and you can give it the function, and then with two MCP server you can convert the LangChain tool into an MCP server which you're running on port number 5000. We can run this and see. It will run the LangChain tool as an MCP server on port 5000. It is actually running it. There's nothing much to see. But what do you do if you have to convert a LangChain piece of code into an A2A server? So here I'm creating an LLM, LangChain LLM, and I'm creating a LLM server using two A2A server. And then I'm creating a simple chain. This is the chain. I have a prompt which goes to the LLM, and there is a string output parser. And this is the travel server which I've created using the travel chain by saying two A2A server. And then I start two threads on port 5001 and 5002 for the LLM and travel server. And here I'm creating an A2A client connecting to each of those servers, A2A servers, and I'm calling those, A2A servers. So you can see the results. Let's run this. It will take some time. It will take some time to execute. LLM result, what is the capital of France? Oh, it did not return the result, it just returned the question. And for travel results, it says must see attractions in Paris include this. So it has executed the A2A agents. One got the wrong answer. What is the capital of France? Because the question was, what is the capital of France? It was supposed to give you an answer, this LLM A2A server, which did not work, but never mind. LLMs make mistakes sometimes. What happens if you want to convert an A2A agent into a LangChain agent? So here you can convert a A2A agent into a LangChain agent, and the A2A agent is running on port 5000, and you invoke that uh, that as a LangChain agent, and you print the output, and then you can use this LangChain agent in a pipeline, in a LangChain pipeline like this. Here you have included the LangChain agent in the pipeline, prompt, then LLM, then string output parser, then LangChain agent, and then the travel info output, and then you can get the results. I don't have anything running on port 5001, so I cannot show you this running. But so that's all we had for you for today. Agent to agent protocol is an amazing protocol from Google, which allows you to connect agents which have been developed with different agent frameworks, create networks, routers, workflows, and you can execute all these agents together to fulfill some task. Now, what is the status of Crew.ai and AutoGen, Semantic Kernel, and NA10? They still don't support A2A agents. Uh, Crew.ai uh, is scheduled to bring in support for MCP tools, but NA10 already has MCP servers and tools calling capability. but none of the ecosystem platforms, agent platforms, have A2A capability right now. So as of now, the only thing you can do with A2A is to build agents in Google A2A and using these examples with LangChain and with the Python A2A framework. That's all we had for you for today. If you have any questions, please get in touch with me. And if you have any use cases that you would like us to help you with, please let me know. Thank you very much.